especially you.
Guys, I have to go.
You are new guy. Before that, let us show our videos.
This video is to make you guys wondering for newbies, and a normal people gonna say, oh my god, the light has turned on itself when it goes into the dark and turn off instead when it goes out to the light. I think there's a demon, evil spirit inside it. But scientifically, it is. There's no such a thing an evil spirit inside the technology. Well, maybe. Actually, there's an explanation behind it, so that's why you have to watch it. Please watch it.
Today I will explain about the lightning dependent resistor. For short is LDR. What is LDR? How it works? What is application? First, we must know the definition of sensor. Sensor is a type of the resistor that can change the resistance value just like a variable resistor. But the difference is the value changed by detecting and responding to the some types of input from the physical environment. The specific input could be light, heat, motion, moisture, pressure, or any of the great number of other environmental phenomena. All these factors are determine the value of resistance of any sensor that we use. In short, light dependent resistance. LDR is a component that can be categorized as a variable resistor that changes the light intensity that fall upon it, which means it just changes the resistance depends on the light intensity. When the resistance change, the current flow also change. The value of resistance that determine how much current flowing through the circuit. This is data sheet for electrical characteristic of LDR type. There are several parameters used in LDR type, such as cell resistance, dark resistance, dark capacitance, rise time, fall times, voltage AC DC peak, current, power dissipation, and operating temperature. We look at the column cell resistance. We see that the lowest resistance is 400 ohm of the resistance. Meanwhile, the highest resistance that can be reached by LDR is 1 mega ohm of resistance. Next, the sensitivity of the photodetector is the relationship between the light falling on the device and the resulting of output signal. In the case of the photocell, one is dealing with the relationship between the incident light and the corresponding resistance of the cell. Now, based on the graph shown, 1000 lux show the highest value of the light intensity. Meanwhile, 10 lux show the lowest value of light intensity. So this is the limit of the resistance in LDR can reach.
The basic things you have to know about how the LDR works in circuit is you have to know what kind of a circuit that's suitable to a sensor. The circuit that we use is called a Wheatstone bridge circuit. A Wheatstone bridge circuit consists of 4 resistors that are connected in shape of diamond with supply source. Point A and point B that you see just right now are 2 voltage dividers. The Wheatstone bridge circuit uses to find the unknown resistance very precisely by comparing with a known resistance value. When we found the unknown resistance, surely the voltage difference between 2 voltage dividers will be 0 and no current flow through it. So that is the reason how it gets balanced. For this case, we use a Bridgestone circuit to turn on the LED by comparing both voltage divider at point A that connected at op-amp as non-inverse input, which means it's positive, and point B that connected at op-amp as well as inverse input, which means negative. When we talk about 2 different voltage divider from Wheatstone bridge that involve positive and negative, surely op-amps will take a part as a comparator. Op-amp or operational amplifier has 2 different input voltage, which mean negative and positive, and a single-ended output. So technically, voltage output will come out with more voltage or signal compared to both input voltage if the positive input voltage greater than negative input voltage. If the negative input voltage is greater than positive input voltage, the output is opposite to the input signal and will come out with negative value of voltage and no currents flow. Then we go to the transistor. As you can see, the transistor is constructed by three doped semiconductor region, emitter, base, and collector, and separated by two p-n junction, which mean BC and BE junction. If it looks difficult to you, no need to worry. A simple way is to look at the transistor as a switch that controlled by an electrical signal, just like UTeM, but this is a more basic one. If you put about 0.7 volt at least between the base and the emitter, the transistor will turn on. Note that this is true for NPN transistor only. There are also other types, but we just need to focus on this one. A bit of current on the base produces a current of maybe 100 times more depending on the transistor through the collector and emitter. We know what is LDR, what is a Wheatstone bridge circuit and voltage divider, we know what is UTeM and transistor, and now we want to show you how the circuit's running in simulation. Tunggu sana. Finally, if the circuit that we designed is working, then we can proceed to the soldering process to make it permanent as a product. But wait, why don't we just see first the application before we solder?
Aduh, hai. Next week nak final. Macam mana ni? Baik aku pergi study dulu lah.
As what we can see in the video lately, every student have a hard time to do when the electric got shut down. So as an engineer, we need to solve the problem in order to get out of this situation. So that's why we designed this by ourselves. We got this idea actually from the emergency light and the laser security. The emergency light will be turned on when the electric in the building got shut down. The laser security concept is whatever object moves through the laser, the system inside it will trigger on. By combination of idea from emergency light or laser security that make us to innovate a new product, the product that can help students to study easily so blackout are no longer the issues. Introduce a study buddy. Study buddy is not an ordinary lamp. You don't need to turn on the light with a switch. Study buddy will turn it on for you. Even your house blackout in the middle of night, study buddy still be with you if you stay close with it. It will rest at the day and active at the night just like owl. I will show you how it really work. Usually, a study buddy will install at the table. Study buddy not going to active at the day even you close to it. But when it gets dark, study buddy will emit the laser directly to the LDR. When you sit on a chair and get your legs in the table, your legs will block the laser from emit toward the LDR, so LDR not going to receive any light from the laser. That's happened, the bulbs will turn on.